Welcome back, everyone. So, we are the last steps of the conference. Let's see if I can go to the next slide. Yes, this is possible. Okay, cool. All right, thank you very much. Welcome back. We are now in the session of the second keynote, and I would like to introduce Koen. He's a professor for intelligent energy systems at the Electrical Engineering Department of the Eindhoven University of Technology. He has extensive research experience applying intelligent and distributed software technologies in energy systems. He was among the European smart grid pioneers with involvement in early developments and field deployments. Currently, he is scientific director of the Megamind research program on technical, legal, and ethical aspects of artificial intelligence applied in the electricity systems edge. Further, he leads numerous research projects in the field. Application of intelligent software in the operation of local electricity systems and in market trade, against the background of the unfolding energy transition, is a key focus of Professor Koen and his team. I would like to welcome you to stage, and I think I need help with bringing the slides to the TV.
Thank you, Sebastian. Also, thanks for the organization for having me. Really appreciate it. So I'm gonna have my talk on a kind of potpourri of topics. My slides are all also not all in the same house style, but that's also showing that it's a potpourri. The main parts are two projects. Already the Megamind program has been mentioned, where we have also among the partners of logos later on TU Delft. And the four larger system operators, the DSO, the TSO, and the other project is a bit more applied and is looking into DSO congestion management mechanisms and how good they are. So without further ado, let's start. So this is me in a nutshell. I won't go very more elaborate on that. I'm combining energy systems engineering, energy markets, and computer science together, and then you have some nice combinations. In my education, I also combine electrical engineering and computer science, and that came together in my PhD on smart grids. So I like to combine things. I'm a system thinker. Two notable publications. The first one is funny, the cover of The Economist. I don't know if people have seen it. I think about a year ago or so, that as an environmentalist, you should not hug trees, but hug pylons. And basically says it all. The importance of electricity for the energy research. The other one is a shameless self-promotion. It's an edited volume on integrated local energy communities, which is about to come out any week now. So first, some AI for power systems examples, just to touch upon the different things that have been happening in our group, Electrical Energy Systems at Eindhoven. The first one is a really nice work already defended in 2023 by Sumaira Demir, who looked at statistical arbitrage trading of autonomous agents on the different electricity markets. Really nice work. Also, the co-supervisor Nikos Paterakis is in the room here. She really made a nice combination of different techniques. Also, the data generation to do data augmentation. the use of technical indicators, which is used in the stock market forecasting. And she brought that together in an agent that decides yes or no to buy some energy on the day-ahead market. Then during the intraday market, which is a continuous trade market, every moment decides, shall I resell it or do I rebuy it? So it does a number of trades over time, and in the end makes a kind of risk analysis whether to close it off on the imbalance market or not. And this agent over time nicely made a profit in the trades. The agent did not do real trades, but if the trades would have been real, then there would be a profit over time. This is now also she works at a energy trade company. And this was also in cooperation with an energy trade company. So this is used. And you can say, well, that's trade. But it's actually helping the integration of variable output of renewables. Another one of George Chaoglou. I always have difficulties with his name. Also, Nikos involved there. That wrote two nice interlinked papers, for which the first one I have this slide on combining optimization and machine learning to manage distributed flexibility. And this is a setup where you have an energy community with an agent that doesn't have the private data, and there is limited communication with the end users, the agents of the end users, and it's the problem is modeled as a Markov decision process. If you're interested, have a look at these papers. Then one of the two larger projects called Megamind. Megamind stands for Measuring, Gathering, Mining and Integration Data for Self-Management in the Edge of the Electricity System. And it aims to look at transition pathways, both from a technical and a regulatory point of view. And we have a nice set of partners there, and also Leonie is involved. And there will be some in my presentation some links of this to discussions that were here in the panel. It's an NWO program in the toegepaste technologische wetenschappen program called Perspective, which strives to have research with an economic and social innovational impact, with a large-scale approach, development of new technology, and a cooperation between scientists and industry. And in Megamind we have 8 PhDs and 2 postdocs, plus a software engineer for part of his time, and 9 partners from the sector. You saw the logos, and 6 knowledge institutes. And the nice thing is that quite recently the software engineer said that he wanted to do a PhD as well. So he is now converted into doing research. As said, the aim is to look at the technology and the regulation, and to look at transition pathways. What we see is a lot of piecemeal, incremental innovations. We have a problem somewhere. We have the technology, but we don't have the right regulation. Then we change the regulation a bit. We have a problem, and it's allowed by the law, but we need to develop some technology, and then we also move a little bit in another direction. By keeping on doing that, we might follow a pathway to a suboptimal location, suboptimal place. So we really need to look at the regulation and the technology together, and that's what we do. The focus is on the edge of the electricity system, and of course there's a lot of edge. We already saw that the low voltage network or the distribution system network of Alliander goes twice around the globe, and the total low voltage networks in the Netherlands goes 5 times around the globe. So there is a lot of system edge, while the TENET networks are only going 2, 3, 4 around the globe. So it gives we have a lot of edge. So we want to create some kind of self-management system that automatically and then dynamically steers energy flows within the technical boundaries of the network, and also while the energy transition unfolds. So the whole system is dynamic, so the solutions also need to be dynamic. Then I have some slides from Tilburg University, TILT, the Tilburg University for Law, Technology and Society, former employer of Leonie. And these are made by Brenda, and she already had, later on there are more, but this one was already nicely summarizing where AI can have an impact. And that's in the management operation of the infrastructure. It's on optimization related to the electricity market, and in communication and local optimization in and around the house with the consumer and the prosumer. And of course, their focus in this project is on this governance, ethical AI, legal part of the research. Then some results from Megamind. The project is still running. It's still going on. So there are results in different levels, and I just picked some random results from the complete palette. One is research which looks at machine learning in systems where there is a concept drift. As I said, we do this for an unfolding energy transition. So you have data from the past, and you train a model, and then you think that you have captured the underlying characteristics of the problem, and then the concept drifts, so the underlying system changes. So there's work there applied to online EV charging. Another one more on the technology, machine learn technology side, from in Eindhoven, the mathematics computer science department, that look at dynamic sparse neural networks for analyzing of time series, classification of time series. And there's some fundamental work is being done on that part. And those two examples, those two researchers, both are PhD students, they now get to sit together to see how they can merge their work, and also talk to industry about use cases that they can use to show it. Another nice example from the TU Delft, PhD student in the group of Peter, that looks at TSO-DSO coordination around the use of flexibility And of course, both the DSO and the TSO can make use of flexibility in the distribution grid. So this is one of the challenges that we have for the future: how we do this coordination, and how we make sure that if the TSO uses flexibility from the distribution grid, that we stay within the boundaries of the capacity there. And Dimitri made a nice work with a convolutional method to make a graphical model, a geographical model of the control space, which is available for the TSO to operate within, in order to make sure that whatever the TSO does with the local flexibility, that it always fits into the network there. Again, if you're interested, the name of the paper is there. Then on to the more ethical AI, transparent use of AI, explainable AI. What are the possible harms and risks of AI in the electricity sector? And then again, these three categories that were already on the earlier slide, with management and operation of the infrastructure. Of course, safety is an issue. Fairness is also something to consider. How responsibilities and accountabilities are distributed over different partners or different actors, and of course, privacy and data protection is important. Optimization in the electricity market, so price issues, congestion also related to the previous one. If we have a flexibility steering algorithm that uses flexibility from the distribution, how do we make sure that we don't cause congestion with other processes also going on in the system? Unclear responsibility. It's a long list, and then of course around HEMS within homes, home energy management systems, things like privacies, data privacy, nudging. What about autonomy, transparency of prices, and also in equal access to technology. And then it was already mentioned, the AI Act. Which of course is highly relevant for this project. And in Tilburg they did an analysis, and I think it's in line with what Leonie already said. First, the act itself, it was published in July 2024. The first parts started to be in force on the 1st of August, and apart from one or two tiny bits, it is fully applicable in 2026. The objectives is interesting: improving the functioning of the internal market by introducing harmonized rules for the placing on the market, putting into service and use of AI systems, promoting the uptake of human-centric and trustworthy artificial intelligence while ensuring a high level of protection against harmful effects of artificial intelligence systems. It's a mouthful. And it's also supporting innovation. This looks quite promising, but if you then look at what exactly is there for the network operators or for the energy sector to be used, then it is not much, and it's also not very clear. The Act follows an all-or-nothing approach with three categories: unharmful, a little bit harmful, very harmful. Very harmful is forbidden, and not so harmful is not really clear what it exactly is. So it says, it doesn't say anything about these non-high risk systems. So it doesn't really say something about ethical use of AI, data privacy, and so forth. And yet, of course, there are also other regulations like GDPR, cybersecurity laws, and the energy law that apply. But it's still unclear what this AI Act is in essence going to do. This is taken from a large slide set, which really dives into the topic. And if people are interested to have a webinar or so, then drop me an email. Then I can relay it, and then we can see what we can organize. Then on to another project where Megamind is a project with PhD students and postdocs. So there is although it's applied and technological development, it has a strong academic touch and feel. The other project where we also were together with TU Delft in the consortium is the GoE project. And basically, if you look at it from an AI glasses, it's about how do we solve congestion with distributed decision making, and then giving somebody a tariff or giving somebody a dynamic price is basically a form of distributed decision making. I won't go into very deep into it, but also the term AI, what AI means, it has been since the 1950s changed every 7 years or so. Distributed decision making has been AI in the past. So we dive now into another presentation, a presentation in the presentation, about how do the network operators approach congestion management and instruments to solve that, and how we have done a large study to compare different instruments to each other. And of course, a question that has been discussed earlier as well. The DSOs have a hard time, and also the TSO have a hard time with keeping up with the energy transition. And if you focus on the local system, for instance, the fuel switch in Dutch households is something on the horizon, which makes this more severe. A problem there is that individual households, they have a tendency to choose for a heat pump over a connection to a heat grid, where a heat grid might be more efficient, and then of course it's extra demand for the network. And there are also developments that happen outside DSO visibility. For instance, operations by BRP in balancing their portfolio. That's completely out of the scope from the DSO. They can only measure that there is something happening which they do not expect, but they don't have any means to prevent it or even to steer those developments. And then what is also worrisome, that some of the older mid-voltage to low-voltage transformers have a protection against short circuits, but not against overloading. So if there is a severe overloading, the thing heats up with damages as a result. And then the question is, can flexibility help to resolve these problems? We started this project where the DSO says, help us how to get flexibility from the low voltage and use it in the mid voltage, but already a little bit in the project, it was clear that we also needed to look at congestion in the low voltage grids. So I go through the instruments, and these instruments have been supplied by the DSOs themselves. So this is what they think of, and of course they follow the EU Clean Energy Package, which gives an order in the things that you can try. Then there is tariff instruments. In the Netherlands, they are thinking about bandwidth tariffs, weighted peak tariffs, and a seasonal time of use tariffs. Then the bandwidth tariffs look like this. So you have a certain bandwidth where you have a lower or the normal network tariff. And if you shoot over, then for these periods you pay a little bit more. Then there is a weighted peak tariff where there is a table which is a kind of fixed table with colors, and then the color gives a weight to your peak. So you might have your highest peak in a green area, but that is then not a problem for the grid, is the expectation, and then you pay extra for the highest peak in a more time slot where there is more, the expected congestion is higher. And of course this is a tariff, so this is something which is fixed and then stays fixed for a longer time. And there is also a seasonal time of use tariff, which is basically a fixed tariff with a changing tariff over time. Then there are market-based instruments. They are for the higher parts in the grid. They are already in the Dutch grid code, so they are already being used. So these are the capacity restriction contracts and the redispatch contracts, market-based instruments. There, the notion of a congestion service provider is introduced, and then here we looked into how the DSOs can use it, but it's also used by the TSO. And it basically gives a kind of two-stage decision problem. The capacity restriction contracts can be activated more than a day before, so before the day-ahead market runs. And the redispatch contract is a bidding obligation contract where if you have such a contract, you are obliged to bid in to a flexibility market, in the case of the Netherlands, the GoPax system. Yes, and so these two, we also did some research in optimization of this problem. Of course, it's a two-stage optimization. If you have a fixed budget, you have to make a decision whether which percentage of the budget are you going to put in the first one and which one in the second one. We published a paper from the point of view of a DSO, and we are now working together with Tenet also to do a similar analysis, but then from a TSO point of view. Then the Clean Energy Package also defines non-market-based instruments like the temporary transport limitations, but that was out of scope of this project. Then we built a large simulation with different neighborhoods, and of course not all the neighborhoods are the same. So in the project, 7 archetypical neighborhoods have been identified by TNO, and then the network operators provided networks for these neighborhoods. And then we simulated houses with different assets, some flexible, some non-flexible, and these assets were based on growth scenarios that are also provided by the DSO, so we could simulate the situation of 2030. And then we had run out of time a bit, but I hope you allow me to go on a bit. We had 3 different scenarios: a business as usual where nothing is flex, a realistic scenario where 50% of the houses has a home energy management system, and 25% of the houses have a dynamical contract, so an hourly price, which is derived from the day-ahead market. And then we also wanted to have an extreme one, and there all the houses have energy management, and all the houses have a dynamical contract. Together with TNO, we built a platform to simulate this, which is available. It's published in a paper, the description of it, the design, and it's also available at GitHub. We presented this at the FlexCon conference, and there was a guy in the back that downloaded it and already ran the models and gave compliments in the question round for how good it looked. So what do we find? We find that growth of controllability and dynamic electricity contracts can reduce peak loads, but with high adoption, it will make congestion worse. So if people start adopting it, it helps, but if too many people adopt it, then it will counteract it. Because of time, I go a little bit quicker through it. I have a link to the report, and we will publish an English paper on it. Another one is that the robustness of the tariff instruments against synchronization with market prices is essential for their impact on congestion problems. So what we see, if a lot of people start reacting to the day-ahead price, then a lot of these tariffs they penalize in the wrong time slot. So that's also a problem. If you have a coincidence of low market prices and also low grid tariffs, then you still have a congestion at that point in time. Adopting both grid tariffs and contracts can reduce these rebound and synchronization effects. We have also the graphs to show that. And but what we also see, and this is the most important finding, that if the congestion characteristics will change significantly if aggregators start doing passive grid balancing. So if aggregators start steering these households based on the imbalance price, the 15 minutes imbalance price, then all these mechanisms don't work. So the conclusion is that we need a new mechanism which connects congestion management better to the value of flexibility in the wholesale markets. So we have also the graphs there. So these are the outcomes that I already mentioned, and then English version of the report is in preparation, is going to be published in a journal. There's an English language interview about the topic and a Dutch report available through the link and through the website. Then to close off, we see a number of trends. We see that electricity use is increasing and synchronizing more because of electrification of transport and of heat supply. We also see that electricity on the wholesale market is more and more traded closer to real time. Volumes in the intraday, volumes in the balancing and reserves are nowadays much higher than they were in the past. And also the flexibility need for the short term is increasing. That's of course the reserves and the imbalance. And we see that more and more flexibility is increasingly sourced from the distribution grids. So the bottom line is that we in our distribution grids will have, we already have challenges, but the challenges are here to stay. They will become more severe, and the question is whether the reinforcement actions will be in time for all these locations. So then the question is, will congestion be part of the solution? Then of course congestion management is one side of the coin, and the better utilization of your networks is the other. So if you have a mechanism that spread the load more evenly out, that's also a form of congestion management, and we do it now like a kind of redispatch or with a tariff structure, but we really need to think from congestion management into how do we increase the utilization of the grid, how do we make better use of those grids. And then these congestion management instruments, they should dynamically also take the value of flexibility on the commodity markets into account, as I already said. And for that you need to see a fusion between systems operation and market operation. Have commodity markets that are network aware or have network constraints as part of your market optimization. And also, as I said before, we need to be aware of lock-ins. We are now doing a lot of innovation in a short time. We introduce a lot of new contracts, group contracts, energy hubs, and we have to make sure that we still have an eye on the horizon to make sure that we don't implement things that form a kind of lock-in and work against us in the future. So we need a new coordination mechanism in the grid. It's in the grid edge, and distributed AI fits this challenge. And as said, questions are how to ensure transparency, fairness, privacy, but also how to bridge the knowledge gaps that we have between the industry and academics in two directions. So what do we learn? Energy transition needs interdisciplinary development. We need a transition path both from technology and from the regulation connected to each other, and distributed AI is a key enabling technology.
Thank you so much. Okay, are there any questions from the audience or some comments? Yeah, I see a hand here.
Thank you for the great presentation. My question is two parts. First, what is your opinion on location-based pricing to address congestion management?
Yeah, that is one of the solutions to connect the global value for energy and for flexibility to what's happening locally. There's also a question about fairness, of course, and so it might not be for everyone. Like now, also not everyone has a dynamic price system. you need to think about if somebody who is behind a congestion a lot of times, are they then paying more than someone else? So you need to have also a pricing structure that makes sure that if you don't participate or if you don't react, that you pay more or less the same. But if you use your flexibility wisely, then you have a benefit out of it.
Yeah. My second part of the question was, when you compared congestion management and the traditional network management, where does something like a dynamic line rating play a role? Because in the transmission side, there is a lot of applicability, but do you see similar application on the distribution side?
Yes, we see. We also have projects on that. A notable project is the Orkest project, which is led by Stedin with a consortium which is looking at dynamic rating of transformers and cables in the distribution system. And of course it's all part of the puzzle. So if you can relax your capacity constraint, then you also give room to the market. But it might not be enough, and then you need some mechanism which take the value of flexibility into account. Yeah.
Thank you. Any further questions? I wrote down a question.
Okay.
So I saw a couple of publications there. One was at NeurIPS, so one of the highest and high-profile AI conferences, but also high-profile conferences, IEEE transactions of energy, etc. My question is, are you using AI in your domain problem, or do you also find findings that would help the AI community in general?
Yeah, both. Yes, both. And the team is quite interdisciplinary. We have people that bring in the machine learning knowledge. We have also in the power systems groups, we have a lot of people that have top-notch knowledge about applying the state of the art or the bleeding edge of machine learning and AI in power systems. And so, we do both. And then this NIPS conference, that is a publication that comes from the Eindhoven Computer Science department. And then others like the one with the TSO, DSO coordination comes from the group here in Delft, and others from our computer science group. And the same holds for the more legal things. And we try to you're in a program together, so you try to interlink. And Leonie mentioned this paper, which was written by somebody from the legal perspective, from the technology, that was also from the Megamind project. Yeah.
Okay, further questions? Yep.
Thank you, Koen, for a very impressive presentation.
Thank you.
I have a question regarding using the low voltage grids out to their approximately maximum, and the implications that might have for the asset management and replacement waves that could be triggered by this type of usage. Is that something that is included?
It is included in these projects like Orkest, where they look into dynamic line rating. What I hear from practice is that transformers, mid voltage, low voltage transformers that are just on the edge, that the short-term solution is to change the fuse to a bigger one, and then take for granted that the aging process is faster, and then you have to replace it earlier. But I think, I started working in demand supply matching before it was called smart grids in 2005 or so. I think my first smart grid publication was 2005 in the AEMAS conference. Since then, we have been thinking about technology to cope with demand supply in systems and to keep everything within the constraints. The big question is, why is it used for the commodity part? We have a lot of virtual power plant companies and aggregators, and there you see these ideas. They are there. They are used. They probably didn't read my papers, but they're doing the same things. But in the network part, we don't, and so the question is, why not? And that's not a technical thing. That's an innovation thing. And there's also inertia in the legacy systems, and we have legacy systems that also are based on incremental innovations. And then we probably already have a lock-in of in these systems. I see Bas smile.
Thank you.
Thank you for raising the asset management question. Just a quick comment based on a little bit of my experience. My previous role was in consulting for the energy utilities in the US, and in one of my former clients, they were doing some of the dynamic line rating work, and they did face issues with transformers, etc. So one of the projects they took up initially as a research project, and then now it has gone live into production, is how can they move from traditional just take the bare minimum data required for control to extending it to actually do longer term monitoring to move from traditional maintenance to reliability centered maintenance. So that was a complete change in their approach towards maintenance, which had to go hand in hand with for DLR kind of programs. So, but it is a big mindset change, and a lot of inertia has to be broken.
That's a good idea. Yeah. Thank you. Thank you for the comment. Further questions?
Yeah, maybe also to connect, we need a number of these mind switches, and of course we for years. For a century, we have had just distribution grids that we just had, and no need to look at them. And they had these old-fashioned meters which pushed up a notch. That after a year you could see, the maximum power flow here was 80% of capacity, so all good. Get back here in 2 years from now or so, and so yeah, we now have the edge computing, and we have the processing power, we have IoT, we have lots of things, and as said, the distribution grids are not very complex in topology because it's mostly radial operated, but we have a lot of it. So we need to go to something which is basically hands off and keeps running within capacity constraints and other boundaries, basically quite automatically. With maybe some flag raised if there's really something going on. So that's the kind of system that we need to think of. And then I see a big knowledge gap between the developments in the distribution system operators around these tariffs. And I know that Berenschot is now writing a report on these same tariffs. While we can show that it's not a lasting solution. So we really need to think ahead.
Thank you. More questions from the audience or comments? Yes.
Thank you for your presentation. I kind of maybe heard you say that you're advocating for a mindset change within DSOs. Can you maybe make that a bit more concrete? Like, what do you think is the biggest mindset change that is needed within DSOs? And from a research perspective, what do you think DSOs really need to adopt what is already in science?
I think the realization that flexibility has a value on the wholesale, and if you want to use flexibility as part of a business as usual, so we're not talking about we are close to a failure and we do a brownout of a part of the system. That's what we're not talking about. We're talking about part of the business as usual. Then the standard repertoire of having a special tariff is not going to work anymore in the phase in the energy transition where we are now. So we really have to think about, okay, how do you make a system which consistently comes up with solutions? A market is basically a solution, or market outcome is a solution that gives solutions that fit in the network. And then also, if you say, well, we switch from energy management to a better utilization of our grid capacity, then it also becomes part of the business as usual, and then a solution which is based on a redispatch, where you first let the market run as if we have a copper plate, and then we say, okay, we have an overloading here, so we pay to market players to change their schedule, and then we solve that. That is something that you can do, on a limited scale, because you everything which is efficient is already selected by the market to be in business. So it's always an expensive solution. But if you do that, 0.5% of the time in 0.5% of your network, that's fine. But if it's becoming business usual, then you really have to think about how do we organize it in such a way that it's cost effective and also robust.
Okay, thank you. Perhaps a very quick and last question.
Yeah, regarding the mindset, I think it's not only in the grid operators, because they are governed by regulation and they have to fulfill what ACM or whatever tells them to, and they have site SIFI and they want to play safe.
Yeah.
But if we have a mindset, we should maybe start somewhere else, at least with the regulator. If I look at the streets, if we would build the streets like our electricity system, then 7 houses would have 7 roads, so 7 lanes to go.
Yeah.
But what's possible now, and you showed beautiful examples of smart grids, if you would have a smart road, we would ride on 1 lane, 200 kilometers per hour, bumper to bumper, everybody, because they would car-to-car communication and all smartness things, so there will be no crashes and full speed ahead. So that's technically possible.
Yeah.
But if the rules for the traffic are not reflected in that idea, it won't happen.
Yeah.
And the same is for electricity. So if we don't get it from the regulatory regime, I don't see it happening soon.
Yes, I think that's an answer to the question why it's happening in the commodity part of the system, because you can do what you want if you stay within the market rules, and not so much in the network part. Yeah, and there with these cars, it's also I worked as a technician in a traffic research center before I had my career in energy. Well, I had a career as a sailor in between, but so it's a long time ago, and I remember small videos of lines of cars with people with their hands out of the window and very short to each other, and this was in 1994. So then it was already possible. So there you go, 30 years later.
Excellent. So I would like to thank you very much for this presentation and
Talking. Thank you very much.
Thank you very much. And now we have the final speaker for today. Who is Joep van der Weijden of the Green Village, who I would like to welcome to us.
No, I get it. Okay, thanks. You're putting the slides in between? Perfect. Right. Hello, everyone. I see some familiar faces, some are new. My name is Joep van der Weijden. I work here at the Green Village. Thanks. As a project manager, I've been working here for 4 years now. And I'm here to tell you a bit about the location that you're at. I know that some of you might know this already, but some are new here. Usually we put this in the beginning of the program, but somehow it ended up at the end, so we're changing things up a bit. But if you've had this talk before, then during lunch, if you walk outside, you have more of an idea where you are. Yeah, now you still have it. Now, with a drink in your hand, you can go outside and check it out a bit more. But so the Green Village, Field Lab for Sustainable Innovation. We've been about 1 year old now, 10 years old now. This used to be the location, sorry about the next one. So we used to be the location of the architecture faculty, but that one burned down in 2008. And instead of putting a new educational building here, some bright minds came up with the idea of making this a space for innovation to be more visible. And that was in the beginning the only guidelines that we had. So we basically accepted everyone who could use our location. So we also had part of a Hyperloop here. We've had some self-driving cars because we have a few special things why it's interesting to use our location, but I'll come to that. Slowly over the years, we moved to be more focused on sustainable innovation and also focused on the built environment. So that's why we have all these houses on our terrain and more and more buildings, basically. How we see ourselves in the innovation funnel is with this hop step jump model. So basically, first you have an idea in theory, or you build something like a first prototype in a lab or in a garage, and when you're done with tinkering in your garage and you want to introduce more of the rudimentary real world, that's when you can make the first hop to the Green Village, because we have real residents here. We have actual installers who start to work with your product, your materials. So you basically see if people are as intuitively using your product as it should work. And you also can compare here, for instance, how does it compare economically to alternative solutions to the problem. But this is the place for testing one system, not 10 or 20, because there are still some iterations to go through. So if you are finished there and you have more of the illnesses out of your system, then you go the step towards pilot locations where you test 50 or 100, and then you're market ready. We focus now on 3 themes. So we bundle the innovations that come to our terrain. The first one is sustainable buildings and renovations. So that one has to do with how are we going to build those 100,000 homes that we want to add to our building stock every year? Are we going to build them with bio-based materials? What type of heating system do we use? Heat pumps or infrared panels or those kind of things. Second theme is future energy systems. This one is closer to heart to all of you, I think. So we have an AC grid, DC grid, heat grid, hydrogen grid, natural gas grid, the real 5G bandwidths, all the infrastructure you might want to play around with, to plug and play, click into, basically. So we have all types of experiments with energy storage materials, different types of PV panels, and also a little bit in the EMS domain, but I'll come to that. Last theme is climate adaptive cities. So basically, we are already experiencing climate change, so it's getting drier and hotter at the same time, or not necessarily at exactly the same time, but at least during the year. So we want to mitigate those issues as well. So we have a water street with more basically peak shaving for rainfall, if I might say to energy experts. And the other one is against heat stress. So the square over here has all different types of innovations that try to mitigate heat buildup in cities. So we are primarily a place for experimentation. So if you come here if you want to learn something, and we have the location for that. For one, since we have exceptions from rules and regulations, so you can test things here that are not CE certified yet. We can build or decommission a building without needing a permitting process for that, because we have exceptions to the construction code, het bouwbesluit for Dutch people. So we can keep the pace in the innovative experiments on our train. That's the idea. Secondly, we have 8 homes and with actual residents. Some are students, some are young people like me starting their careers. We have a PhD or somewhere. So basically ordinary people that you use as guinea pigs. They sign a guinea pig contract. They accept that sometimes it might be that their home is not heated anymore because it's a uncertified heat pump that's being tested, and it might not work 100% of the time. So this happened once on a Friday evening, and colleagues of mine had to come back to fix the heating for the weekend. But that happens. So the residents accept that this is their way of contributing to the different changes that we're going through as society. Let's call it that. Next to the experiments, we also a place for displaying and to connect. So we have a lot of visitors like you here today. We've had the king, the queen. We even had prime ministers from other countries visit here because it's just a visible place for seeing the future a bit. So it's also basically a demonstration place where even if we've had parties that didn't really want to experiment, they just want to showcase their products here, like a showroom. We're not a showroom. It's something additional to the experiments if you experiment here. And lastly, your learning community. So we also see that the different parties that come here learn from each other. The blue ocean mindset is quite picked up here. So the knowledge is shared quite broadly between the startups as well as the scientists. And I mainly mentioned most of this. Something went wrong with the slide here, but we have one event center. This one also quite innovative, actually. We have 13 residents, 25 employees, colleagues of mine. Our office is here across the street. We just have a brand new office. We have quite a lot of visitors. These 20K are the active event visitors, but we have about 50,000 people in total who just walk over the train. So quite a lot. And our data platform is catching up as well, and that's my domain, but I'll tell you a bit more later. Since we're here at the TU Delft, you would think that most of the people here are coming here are engineers, which is partly true. We are not owned by the TU Delft, so we are our own non-profit organization. So everyone who wants to use our facilities is open to knock on our doors. Since we're in Delft, we do have mostly technical experiments that come to us. At least that's the way that they start. And then along the way, they find out that actually they also learn something about the business models. How does it compare to other types of energy storage? The rules and regulations. So even though you have exceptions here, you do learn which exceptions you actually need and don't have in the actual world, or which type of certification installer needs to work with your materials. And lastly, the consumer side. So since we have actual residents, you also learn something about the societal embracement of your product or innovation. And there's all these different types of challenges. For each project, it's different. So some are about the safety. So we've had recycled scooter batteries to use as a home battery from the Felix green scooters, for instance. Not in the building decree. So for instance, this entire building is built on 100% recycled concrete, which is not allowed to be used in buildings because of the construction code or the building decree. But nowadays you can actually build it quite strongly. So we've built an entire glass building on top, and it's still working after 2 years. No cracks in the glass. So maybe we should change the building, the construction code. But those kind of things pop up in all these experiments. My program specifically is called Digital Energy, which is also why they picked me to tell you this story today. So I focus on the digital innovations on our terrain. In essence, I try to gather as much data, energy-related data as possible, and I also try to make as much of the assets on our terrain controllable, so that you can learn and experiment with energy flexibility here. So we've just heard a bit about the HEMS concepts. Basically, all of the 8 need to become HEMS houses, of course. I want to offer basically the location to learn how to control all different brands of PV inverters, all different brands of home batteries, different brands of heat pumps, you name it. So that's my goal for now. If you do want to experiment in this and think that you could use our data sets, or you could want to experiment with algorithms here, please reach out. Maybe we can see if there's something possible there. I think that's it. Yeah, that's it. So I won't keep you longer. This is the end of the program, I think, for you. There's drinks. Yumi, drinks in the back? Yes. Okay. Thank you very much.
Thank you. It's super interesting. I'm learning every day. Super cool. Thank you. Okay, this brings us to announcement and closing. Oh yeah, I need another arm. Okay. Thank you so much. Yeah, let's see. So we come close to the end of this conference. What do we have? Okay, you already know these people. Not too interesting. We would really like to thank all of our sponsors who made this possible. We heard about the Green Village. Thank you so much for this. Quantum Delta Delft, QTech, Convergence, and then the Institute for Computational Science and Engineering, and of course the PowerWeb Institute. So I think this deserves another hand, big hand, and round of applause. And, well, what is this? So, no, this is not the... right. Yeah, see? Everything is planned.
Hello everyone, so I am here on behalf of the newly established IEEE student branch of TU Delft and the Power and Energy Society. So we will be having our first event on 29th October, and also as a part we are introducing the board and what as an IEEE we try to establish. So it's a fun event. We are trying to conduct a quiz in the Slash Pub under the building of EMCS. So everyone is welcome to join, so you can just refresh your memories, what you learned today, and maybe through your research, and with a free beer and some snacks. And it's a great opportunity to network with others. So hope to see some of you there. And so thank you for your attention.
Thank you. I will leave the QR code a little longer. There is a photograph. Yeah, perfect. Yeah, thank you so much. I think I will be attending this. Very good. So what do we have? Yeah, the organizing team. So thank you so much, Yumiko, for all this preparation. We got flowers. Thank you so much for everything that you did. Okay.
Yeah, I jump in for Zeynep, who isn't here at the moment. So if you caught fire for quantum computing and thought, well, I always wanted to know how to do it, but I don't have a D-Wave machine in my Kelder, we organize a hackathon on that. 3 days in November. First day is really hands-on practicing how to formulate a QBO, so how to formulate your problem into a QBO. And then the next 2 days is really, solving some challenges. You can bring your own problems. We bring some problems. We ask Tenet, Aleander, etc., if they have some problems that are interesting. Yeah. So if you want to learn a little bit about quantum annealing in particular, you're more than welcome to join for these 3 days or one of the 3 days. And again, I leave the QR code for a second. There you find all the info. Yeah. Thanks.
Excellent. Hackathon. Also, 1,000 thanks to Pedro. I think he's not here anymore, is he? No. So he also helped a ton. So this was really a huge team effort. And you see him all day. So working here with the technique, with the photographs, with the sound. So there are so many people helping. With creating this conference. So Alex, Cecile, Maria, Lily, Mani, Zaraf. Thank you so much. And perhaps Perhaps representative for the other people, Lily. So yeah, for you as well. Thank you so much for the assistance. Thank you. Well, I think. What do we have now? I have another thank you. Namely, perhaps Matthias. Perhaps thank you for being here, for attending the whole day. It was a pleasure talking to you. And I think the very last word I would give to you.
Yeah, okay, we squeeze in something.
Before the conference chairs close, 2 small things. I was approached by many people about the Green Village. How did you get the exceptions for the permits and how does the business flow? I told, wait for Joep. He's still here. So if you're still here, just approach Joep. The second thing is, after the Borrell, since we have a guest from the UK, I will do a very, very secret VIP lab tour over there. So if you haven't seen it before, you can join us. And
So what else could I say to top the lab tour? I think nothing except for thanks for being here and enjoy the Borrell. I think the drinks are open now. Thanks.